Okay. In the previous class, we have given introduction about forecasting, and we have discussed a little bit on the trends of demand, right? How the demand is varying with respect to time, and we have seen trend variation, cyclic variation, seasonal variation, all these things, right? And also, forecasting is divided into two categories. One is qualitative, another is quantitative. Qualitative is also known as subjective, and quantitative is also known as objective. Qualitative in the sense we are using human intuition. We are not deciding the forecasted demand or forecasted value with respect to some data. We are doing with respect to the experience of the human. That is what is judgmental techniques, they say. So we have 4 different techniques. We have discussed each one of them: opinion survey, market trial, market research, and Delphi method. In Delphi method, sometimes Delphi they say, sometimes some people even call as Delphi, but I am comfortable with Delphi. So if somebody is saying Delphi, please do not mistake that person. It is Delphi or Delphi, anything is fine. So Delphi method is, I told you, it is one of the best method in judgmental techniques, where all the expertise people are meeting in common place and sitting for a roundtable conference, where some questionnaire is posed to the uh, members who are participating in the roundtable conference, and then certain answers will be taken will be noted down, and through that answers another questionnaire is provided, and as the round proceeds, like from round 1 to round 2 to round 3, what happens, the demand or the forecast value what individually they are saying might be differing in the initial round, and towards the end of the rounds, all maybe 5 6 rounds, so everyone will converge to a same or approximately same range or same point, they say. So that is what is the forecasted value for the coming year or month or week, whatever it is. Okay, and I stopped at this point in the previous class, so let's continue from there. So if you see here, we are having quantitative, in the sense I told you already. We are going to discuss about data. So we are going to do something with the data. In that we have time series analysis, another is causal or econometric. Time series is nothing but time is related here. All the things is related with time, means time series in the sense some past data is given to you. Some past data is given to you with respect to time. Time is very important here. So you can use that past data and try to figure out the forecasting value or the prediction value by using these 4 techniques. One is past average technique, simple moving average, weighted moving average, and exponential smoothing. So first we'll cover these 4, and then we go to causal or econometric. Here it doesn't depend upon time, but we can correlate, or we can do regression with any dependent versus independent variable. So here we have something dependent on something independent, right? Let us say there are some 2 variables, x and y. Let us assume that x is independent of something and y is depending on x. I can write y is function of x. Y is function of x. So in such cases, we'll be able to derive that function in correlation and regression analysis, or we'll be seeing the trend of the variation of x with respect to y, or y with respect to x in correlation analysis. So this two also will be discussing. Fine. So let's discuss the time series analysis. And all the things we have discussed in the previous class. Okay, time series. So the data is posed like this. How is that? Here we are having some year and demand, and the year for 2015 the demand was 240 for some product, and for this is what has happened already. 240 customers or 240 products have been sold off. Demand, that was the demand, that was the consumption that has occurred on so and so year. And in 2016 we had 310 products that have been sold out, or maybe the demand has been fulfilled. So this is the real that has occurred. So like that, all the things we have the data till 2021. So what do you want to find? I want, because 2022 hasn't completed, right? So in 2021 only you have to forecast the value of 2022. What can be the demand in 2022? That is the forecasted value. So that's the reason why we are writing F 2022 as the forecast value in 2022. So that is what we have to find. So we have all the data, right? We have all the data till 2015. From 2021, 22, we go back in time. You have till 2015. Right? So what does this first method says? It's a past average method. So what is the past average method? Take all the data of the past that you have and average it. That's it. Right? How many data points we have here? 1, 2, 3, 4, 5, 6, 7. There are 7 data points available. Right? So what do you do? This was demand of 2021, demand of 2020, demand of 2019. Like that, you add all of this. That is what is the demand of 2021, 20, 19, so on so till 2015. Divided average, you're averaging, you're dividing by 7. So 430, 390, 350, all summation of all these values. That is what is this? Divided by 7 will give you 340. So you're expecting, or your forecasted value is that nothing but 340. You're expecting that in 2022, 340 products will be sold. You're expecting it. It didn't happen. Until unless 2022 is completing, you don't know what is going to happen. But you're expecting that. How did you expect? How did you predict it? By averaging this stuff, averaging all the past available data. Okay. But here, let us assume that I have data from 2021 all the way back till 1980, right? So it's 30 years, 1990, sorry, till that. So if you're having till 1990, it's 31 years of data. But let us assume that product which was launched in 1990, and the product, let us assume that the product is still in use till 2021, but it might not be used with, it's not in usage with a very high number of people in the society. For this example, for this kind of case, let me tell you an example. If you see any car company, okay, let's say car company. Let us assume that we have this company. What is that? Maruti 800. Maruti 800. Have you heard of this car? The basic car. Back in days like in 1990s or 1990, 2000s, we might have seen so many Maruti 800s on road. Right? Now, how many Maruti 800s can you see on road? Is it high or low? Right? Obviously, it is low. So if I had data from 1990, 1991, right, so on, to 2015 to 2000. So 1990, the demand used to be high. Maybe it is 2000. In 1991, it has increased to 4000. We don't know. But if you are adding all the stuff all the way back till 1990, all the data available, what happens? Your forecasting value might go up. It might show you 2000 is your forecasting value, because the weight that you're putting for all the values are same, because the speciality of 1990 is same. The speciality, the 1991 also is treated the same. 2015 also is treated, because over the period of time something has changed. So many models have come, so many technology. There is so much technological advancements that have occurred, but we are giving weightage to each value as same, right? You are just 1 into 390, 1 into, you are giving weightage, equal weightage to every, this thing, right? And also you're taking all the way back till 1990. That is not good, isn't it? Because if you're doing that kind of thing, the forecasted value will be more, and that's not the case. So to avoid this kind of thing, what we're going to do, we're going to do the next one, that is simple moving average, right? Simple moving average. What is simple moving average? It's nothing but, I will not consider all the way back. I will not consider from 1990 from here. What I'll do, I'll cut off somewhere. I'll say that I will consider some period which is very recent. In this case, I'm taking some four values. In the sense, here I'm saying that n is equal to 4. So that is what is written. You calculate the rolling average of constant period. That very recent period. I will calculate the average of these 4 values. That's it. If you say no, I just why 4 values, I say you consider 2017 also, then I'll take n is equal to 5. This, is it 4, is it 5, is decided by you based on the experience or based on the trend that is going on. Okay, so let us assume that in this case, if n is equal to 4, n is equal to 4. If n is equal to 4, then obviously I will take only 2021 back, 20, 19 and 18. Then I'll take all the values of this and then I'll take the average of it. So obviously I am taking n is equal to 4, then demand of 2019, 18, 17, 16. Here I think I wrote very okay. Okay, fine. What I'm calculating? Sorry. Let us not discuss this. First, you have to discuss this. Okay. So here we are taking 430 plus 390 plus 350 plus 3. So for the forecast of 2022, we are getting 368. Because you want the forecast of 2022. Let us assume that I want to, let us say we are in the year of 2019. This year we don't know anything. We don't know anything of this data. If you want to calculate the forecast of 2020, what I'm saying is that let me tell you that we don't know any of this data. We don't know. Now I want to calculate the forecast of 2020. What did I do? I've taken, and here also n is equal to 4. N is equal to 4. So what did I do? I've taken 2019, 18, 17, 16. That is what I did. 19, 18, 17, 16. Divided by 4. That's the reason why 350 plus 300 plus 360 plus 310 divided by 4. That is your result. So you got the forecast of 2020 like that. So if you are proceeding, let us assume that I'm done with 2022 also. In the year of 2022, I had some demand of 400. Even though you forecasted 368, but there was a demand because it's not sure that whatever the forecast that you had made will be true, right? Let us assume that 2022 also is completed. Now I want to calculate the forecast of 2023. So which are all the years I have to add if n is equal to 4? Which all of the years I have to take the average? Anyone? Anyone? If I want to calculate the forecast of 2023, which years I have to consider for taking the average? Yes. No, 22 also you have to consider, no? 22, 21, 20, 19, because 22 already value is there. Yes. Yes, Navin, you're right. So then that is what? That is what is your simple moving average. Who is moving? Data is moving. Based on the value that you want to find out, it is moving. That is what is your simple moving average. And here in the previous case, it was not that good because we are considering all the way back. We are discarding all the values which are out of trend. Here the trend is maintained, right? But here the drawback is how much n we have to consider is a big problem. How much n we have to consider is a big problem. Is it 5 years back we have to consider? Is it 10 years back we have to consider? Is it 11 years back? We don't know. We are not sure about it, right? Somebody says 10, somebody says 5, somebody says 20. It's a very big problem here. So n is creating a problem. Again, to avoid this, what we have done, we introduced this, and we have been introduced to this weighted moving average. What is this weighted moving average? So the weighted moving average is nothing but, okay, here let us assume that again we know the value of n, but last year is important than this year, right? Then than this year. Isn't it like if some product is there? Obviously, the sales in 2021 is more important than sales in 2018, isn't it? Isn't it? Because last year is very important then. So what I'm doing is that instead of assigning equal weightage to all of these 4, I'm assigning some weights which are not equal, and that to descending order, right? So I'm trying to find out the weights first. So how do I find the weights? Weights are nothing but if you have n is equal to 4, then you can find the weights by using this method of digits. So what is method of digits? Method of digits is nothing but your weight number 1 is this, weight number 2 is this, weight number n is this, right? Just n by summation of n, comma n minus 1 by summation of n minus 2 by summation of n, so on, so on, so on. Like that, you are getting 1 by summation of n. Okay, fine. So what is summation of n? Summation of n is n into n plus 1 by 2. So that's it. If you have summation of 4, how much summation of 4? If you have n is equal to 4, summation of 4 is 10. That's it. N, that is 4 by 10, n minus 1 3 by 10, n minus 2 2 by 10, 1 by 10. And these are the weights which are descending order. If your n is equal to 5, and this will be your weights, 5 by 15, 4 by 15, 3 by 15, 2 by 15, 1 by 15. So these weights are every weights that, like for n is equal to 4 and n is equal to 5, all the weights have been arranged in descending order. Now that is what we are going to do. What we are going to do, if n is equal to 4, your weights are 0.4, 0.3, 0.2 and 0.1, isn't it? So what I'll do, 0.4 into 430, 0.3 into 390, 0.2 into 350, 0.1 into 300. That is what I have done. See, 0.4 into demand of this thing, 0.3 into demand of this thing, 0.2 into 0.1, like that. You see, this is what I have written here. So what I did here, the good point is nothing but the weights, or whatever is there, I'm giving more weightage to the recent period. Recent period, I'm giving the most weightage. Then I've lessened. I mean, I've reduced the weight to the previous year, right? And then I'm keeping on decreasing the weight as we go back in time. So that is what I've done. So that makes good, right? Because you are giving good importance to the previous year. That is what is going to happen in nowadays, isn't it? Right? So now, as I told you, 0.4 into 390, 0.3 into 390, 0.2 into 350, 0.1 to 300. You're doing this, and you're getting the answer as, and of course, this is average. So you just add 0.1 plus 0.2, that will be equal to 1 only, because this is summation of n is equal to what you say, n into n plus 1 by 2, right? And there we are, our weights are n by summation of n plus n minus 1 by summation of n plus comma n minus 2 by summation of 1 by. If you're adding all the numerators, the numerator will be summation of n only, right? So that's the reason why we are dividing it with 1 only, and you're getting the forecasting value of 2022 as 389, right? So if at all you're considering 5 periods, then obviously 5 by 15 into 430, 4 by 15 into 390, 3 by 15 into 350, 2 by 15 into 300, 1 by 15 into 360. That is what we are doing, and that is what we have done here, and then we got out 381. Okay, fine, sir. You already told that there is a problem of n, which n to you have to select. So the n problem is there in weighted moving average. That is what is called, that's the reason why we are saying it as weighted moving, because we are weighting, we are giving different weights to the demands as we go back in time. And here also there is a problem of n. This is a simple moving average. So to avoid that, what we are doing, we are going to the next one, that is your exponential smoothing method. In this method, what we are going to do, we take all the demand points. Let's say now this is 2021. We have data till back till 1990. We have so many years. This is 31 years of data we have. 31 or 32 years of data. Let us assume that. Okay. 1990 also is considered, right? So 32 years of data is there. Okay, I'll find. But what I'll do, I will assign larger weight to this, then little bit of lesser weight, then I'll reduce the weights. And here the weight is very negligible, that this value is not even considered. So now initially what it will we do, here we have assigned weights to each of this thing, and that weights are linearly decreasing. The weights are linearly decreasing, 0.4, 0.3, 0.2, 0.1 are linear decrements, right? But here we are decreasing exponentially. The weights are exponentially decreased. The weights in 2021 is very high, then exponentially decreased, then exponential decrease, exponential decrease, exponential decrease. Like that, as you're exponentially decreasing, the effect of 1990, the year of 1990 is not at all considered at all. But still you're considering the data point, but the effect is not shown in the forecasting. So this is the good one, and this is what people generally use with some modifications in this. So now what we're going to do, we are going to find out the general expression for forecasting of time period T. In the sense, like in the previous case, 2022, this is what is T. And we have data till 2021, we have data of 2020, and we have data of 2019, and so on back. So if we want to find out Ft, that is 2020, then we have, this is dt minus 1, this is dt minus 2, this is dt minus 3, all the data points, all the demand values what we have, right? So alpha is your weight into dt minus 1, the recent data, and alpha into 1 minus alpha, it's an exponential decreased value compared to alpha, into dt minus 2, alpha into 1 minus alpha whole square, alpha into 1 minus alpha whole cube, into dt minus 4 till infinity. You can have infinite amount of data points, it doesn't matter, but still you're considering the data point as well. Okay, but the important point is that this is exponentially, you are exponentially decreasing like this. You keep on decreasing, exponentially decreasing. Initially, for 2021, you are considering more weight. 2020 lesser weight. As you keep on tying it, and you are almost coming it to zero. Exponentially decreasing weight. Okay. So now here in this case, alpha is nothing but exponential smoothing constant. It is a weight, but not exactly weight, because here alpha is weight, here alpha into 1 minus alpha is weight, here alpha into 1 minus alpha is weight. So alpha is exponential smoothing constant, and that alpha lies between 0 and 1. Okay. So now this is your mother equation or the basic equation. Now what are you going to do? We are going to do some manipulations, and then we are trying to find out. We did some manipulation. So this was the original equation. Then what I did, I have taken from this part, these two are same. Okay. From this part, I am taking 1 minus alpha common. If I take 1 minus alpha common here, then alpha and dt minus 2 will come here. And if I take alpha, 1 minus alpha, alpha into 1 minus alpha into dt3, so alpha, this 1 minus alpha will go here. Like that, I have taken 1 minus alpha common. And what is this? This is nothing but forecast of previous year. I want the forecast of 2022. So 2000, what is T minus 1? T minus 1 is forecast of 2021 as well, because for 2021 also you might have forecasted something, but you had the value of demand value, because demand value is actually occurred. This is what you have forecasted. There might be same, they might be differing. But demand of 2022 hasn't. There is nothing, because 2022 is still in proceeding, right? It's not haven't completed, but you have to forecast. So in this thing, what we need to have is that forecast of previous period also we need to have. If we have demand of previous period and forecast of previous period and exponential smoothing constant, that's enough. Then you can find out the forecast of next period. So alpha into demand of previous period plus 1 minus alpha into forecast of previous period. That will give you the forecast of the next period. That's it. Okay. Or else I can do like this. Just I'm manipulating it. Same formula. I'm just opening the brackets. This is alpha into dt, alpha into dt. This is f into t minus 1 plus minus alpha into ft minus 1. Here, instead of taking ft as common, I'll take alpha is common. So ft minus 1 is here. Here we have alpha into something. Here we have alpha into something, and these two will go here, right? And I can write the formula as ft minus 1 plus alpha into dt minus 1, demand of previous period and forecast of previous period. So I told you that dt minus 1 is the period demand of previous period, ft minus 1 is the demand forecast in the previous period. You forecasted some value, maybe 230, and you got a demand of 210. So obviously This is what is the error, right? Because this is what is the error that you have did. So you told 230 will be the value of that might happen in the future, but it didn't happen. 210 happened. So there is an error of 20, right? There is an error of 20. So that is what is error here. So if you want to remember, you can remember this formula or this formula. If you want to remember both, it doesn't matter. But this is, but where did this come from? This come from the mother equation. Okay. Is it clear, guys? Any doubt? Okay. Okay. Fine. So now we have what we are going to do. In some cases, especially in engineering service examinations, this alpha is not mentioned. But don't worry, in HL and GATE they'll give you the value of alpha. Some cases what will happen? This alpha is not mentioned, and this is the formula of alpha. That is n by summation of n. Some period is mentioned, then don't worry, this is very abstract idea, but sometimes we can use this if n is not mentioned in the examination, and the formula will boil down to 2 by n plus 1. Otherwise don't do one thing, forget about this, don't remember, forget. Okay, and the important point that you have to note is this, that is the this one, that is data. If data is more data means like very fast data, so much is there, 2020 2000 until 2021, that is what is your 21 years, let's say. Okay, so you can use exponential smoothing. You know why? Because you can alpha into 1 minus alpha, then alpha into 1 minus alpha whole square, then alpha into 1 minus alpha into whole to the power of 20, like that. You can keep on decreasing the weight, right? Or else you can, if data is less data is there, then you can go for SMA or WMS, because this is what is moving average. You are doing the moving average, and in first case you are doing simple average, and second case you are doing the weighted average. Okay, so that is these two are very important points. Okay, next is this responsiveness is nothing but the stability, and responsiveness is nothing but what is that? If at all your time period is very less, then you see the curve is so responding, means like small change in something will be leading. But for a longer period, your curve will be stable, because you have data from 1990 to 2021. Sometimes if you are drawing the forecast, then it will be same. But if you have very less amount of data, then it is very responsive. Okay. So, and the stable, or how when does this stable happen? When does, for every time, as the time is increasing, in 2015 also you have same demand, and approximately in 2021 also you had the same demand. When is this going to happen? When the a product is very well known and very let us say HP, some laptop, HP laptop, it's not a specific configuration, some HP laptops. In 2015 also it made a business, of some 2000 laptops demand, and in 2021 also it will make 2000, approximately 2000 laptops. Why? HP is very well known. But if you have some new product, that new product might go up sometime, might come down some, might go up sometimes more. So this is what is your responsive. If something is responsive, then alpha is 1. If something is stable, then alpha is equal to 0. You know what is alpha? Alpha is nothing but exponential smoothing constant, which is lying between 0 and alpha less than 1. We know that, right? Alpha is 0 less than alpha less than 1. Fine. So this is the condition. If n is tending to 0, that is your data points are very limited, right? If you have very limited data points, then it is very responsive. Then when it is responsive, then you can substitute ft is equal to dt minus 1. We know the formula, right? Ft is equal to alpha into dt minus 1 plus 1 minus alpha into ft minus 1. and I'm saying that n is tending to infinity. When n is tending to infinity, alpha will tend to 1. If you substitute alpha, so the second term will be going up, only first term, and this is 1. So ft is equal to dt minus 1. Okay. So if you are trying to find out the data, like if n is more infinity, in the sense you have so much of data, then if you are substituting, you already know alpha is 2 by n plus 1, right? So if n is tending to infinity, alpha will tend to 0, right? If that is what alpha is tending to 0. This is what it is, and that is what is the limit of stability. So then, if according to this formula, if you are substituting alpha is equal to 0, so this term will be going off. Only this term is left, and that is what has been done here, right? Ft is equal to ft minus 1, right? So this is the graph. If you see here, the 0 is telling the stability value and 1 is telling the responsive value. Okay, please do remember these points. Okay, next one. So that's the end of all the 4 methods: fast average method, simple moving average method, weighted moving average method, exponential smoothing method. Is it clear, guys? Any doubts in this? Hello? Everything is clear? Yes. Let's proceed. So there are forecasting error. We have already seen what was the error. Forecasting error is nothing but at certain time period, some time period t, you have demand value and you have forecasting value. So demand value is what has actually happened. Forecasting is what you have predicted. So there might be difference between what has actually happened and what you have predicted, and that is what is your forecasting error. And that error is not only the difference between that, you can have different metrics for that. Okay. So the forecasting error metrics are like this. Okay. What are those? First one is mean absolute deviation method. Mean absolute deviation. What is that? Simply, you are just finding out. Sometimes it happens that your expected demand, the actual demand which has happened can be more than forecasting, or the forecasting can be more than demand. If your demand is more than forecasting, in the sense you are having shortage, right? And if your forecasting is more than demand, then you have surplus values. You have surplus amount of values, right? So here in mean absolute deviation, you will not be able to identify the distinction because you are taking the absolute. You are taking the absolute. Okay. Sometimes D is more, F is more, it doesn't matter. You are taking the absolute value. So that is what is here. Just seeing how much is the error. Whether it is more or less, I am not caring. Whether it is surplus or shortage, we are not caring. But I want to know the error. How much is the error? That is what you are taking as the, the absolute value of all the periods, because for each period you have demand forecast, like that you have for all the periods you have. So this minus this absolute value, this minus this absolute value, plus this minus this absolute value, you keep on adding it, and then you find out the value of. Okay, fine. And another one is nothing but mean forecast error, or it's also known as bias, or it is also known as bias. So if you see, sorry, okay, yeah. First, for finding mean forecast error or bias, we have to find out running sum forecast error. The running sum forecast error is given by this formula. Running sum forecast error. Okay. So what is that, sir? What is that running sum forecast error? It's nothing but here same formula like this only, but without the absolute. Here we have absolute, we have this absolute value, but we are not putting any absolute. So it can be positive or it can be negative. But here Here only positive is allowed because you are taking the absolute value, and that divided by the n will give you the mean or MFE, right? That is what is your mean forecast error or bias. Okay, you have to remember all this formula. There is no other option. Here, what they're saying, overestimation. If your value is more, demand is more than forecast. Wait, yeah, demand is more than forecast, then underestimation, right? Yes. Then, if at all, if you are having a negative value, it means forecast is more than the demand, then overestimation. You have overestimated it. The demand has not come. The demand is has never reached the forecast value. Okay. Next, another is mean square error. Mean square error is nothing but we are just zooming the value. We want to zoom the value and see what is the error, because sometimes the error might be small fluctuations present. You want to zoom it. To zoom that, you are scaling the values of the error. So that is what is your mean square error. And sometimes you need the percentage, with what percentage value the error is there. So even then you are doing mean absolute percentage error. So here also please remember this is absolute percentage error. Okay. And last one is nothing but tracking signal. Tracking signal is like the formula is running some forecast error. What was running some forecast error? Running some forecast error, if you remember the formula, it's nothing but summation of n is equal to 1, sorry, summation of I is equal to 1 to n. It is without any absolute di minus fi, right? That is what is your running some forecast error. And if you remember what is MAD, MAD is nothing but simply summation of I is equal to 1 to n and absolute value of di minus fi divided by n. That is what is MAD. Okay, if you're dividing these two values, then the resulting will give you tracking signal, and 0 will be an ideal value, but it can range from -5 to. Okay, is it clear, guys? Yeah. Next, there are some problems. Yeah. Now let's enter into the other one, that is partial or econometric. Partial or econometric. Okay. So in partial or econometric, I told you already, there is some independent value and there is some dependent value, and this is your independent. So here T is independent. Okay, and D is dependent. So that's the reason why f of independent value is equal to something dependent. Who is depending on who? D is depending on T. Okay, fine. Now, if you see, we want to find out, obviously, when you're plotting something, independent value will be plotted on x direction, dependent value will be plotting on the y direction every time, if you see, because we're writing y is a function of f of x. Every time we write like this, right? You will never write x is equal to function of y. You'll write it, but generally you use this kind of notation, and you say that x is independent and y is dependent, isn't it? So now some data points are there like this, because at t is equal to some value, d is some value, at t is equal to value, d is some value, at t is equal to some value, d is some value, like that. You have some points. Now there are some data, and you want to, with this data, these are all the data points, right? These are all the data points like this. With this data point, we should be able to identify some trend or correlation. What is happening? How demand is related to time? And if you can find that correlation, and if you can find the correlation, then that is what is correlation analysis. Or else, what we can do is that we can take the values of some data points like this, all the data points are like this, like this, like this, like this. Then I'll say I will fit a curve. I'll fit a curve. I'll fit a curve, and with this curve will represent all the data points. The regression. This is what is called regression analysis, and this is what we'll see in the today ML or DL, deep learning, or maybe all these techniques, machine learning and deep learning. All these things are having this regression analysis. If you're seeing, right? So we'll see both the analysis, correlation analysis and the regression analysis. In the correlation analysis, what we're going to do, we are trying to see the trend, and please see, this is your y and this is your x, this is time, this is demand. D is depending upon t. So if your points are like this, 1, 2, 3, 4, 5, 6, 9, all these points are like this. So now let us assume that we have, this is x1, x2, x3, x4, all this is x1, x2, x3. Okay, let me take ink. So this is x1, x2, 3, x4, like that we have till some xn. And what is this? y1, y2, y3, y4, like that we have till yn. Okay, and you can represent x bar as mean, that is x1 plus x2 plus so on till xn divided by n, that is your mean. In the similar way, y bar is represented mean of y values, y1 plus y2 plus y3 so on till yn divided by n. That is what is your mean values of x and y bar and x bar. Okay, so you can find out a correlation constant with this formula. If you see, this is your formula. Okay, let me take different word distinguish. You can find the correlation, this thing, that is summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square into summation of x minus y bar whole square under root. If we can find, then we can find the trend, that is r is equal to +1, means it is in a positive sense, it is going linearly like this, and r is equal to -1, linearly it is reducing. R is equal to 0. There is no trend at all. I don't know how can I relate these points, because sometimes if you take at t is equal to some value, you have different demand values. Here for a single t, one demand, but here different demand, because you are unable to relate. So if r is equal to 0, means there is no correlation. D and x are not, D and t are not related. So, and also please remember, correlation value is lying between -1 to +1. That is what is correlation analysis. Okay. And next is nothing but linear regression. What is that? I told you already. You have the demand points. Demand point 1, demand point 2, 3, 4, 5, 6, 7. You have demand points with respect to time. For t time 1, you have demand d1. For t time 2, you have demand d2. T time 3, you have demand d3. Like that, you have so many points. Okay, and now I am fitting a curve. I'm fitting a curve like this, and that curve I'm fitting with least square, minimizing the least square function. What is the least square function? If you take any point, on the curve, right? Because this is the curve. Okay, let me remove all the things. So if you take this curve, actually this is the actual point, but this is for time t, some time t2, let us say. T2, the demand value is exactly this. This is your T2. This is your original value. But you are representing this line, right? So you're representing this line. So if you take this point, this will be your predicted value. And this T2 minus F2 whole square, or maybe you can say as in this function, the actual value, y actual value minus y predicted value whole square is the function. we want to minimize this function, and we have to minimize this function and try to get this line, and that is a straight line. That is why it is called linear in the first place. So we have y is equal to x plus b curve, and this is your prediction curve, prediction line, and a is your slope. Intercept is nothing but this one is intercept a, and b is the slope. B is the slope. Okay. So now once you have a is equal to y is equal to a plus bx, in the sense y is equal to, or you can say like this, d is equal to a plus bt. Now I want something in future. Let us assume that this is 2021. I wanted 2022. I can extend, no? I can extend this value and I will find the forecast, because this is a forecast curve. Anything might happen, but on an average it is trying to predict some value which might occur with minimal error. So I'll just substitute t is equal to 22 or some value like that, and then I'll find out the value of t. So that is what is your linear regression analysis. Is it clear, guys? Sir, no? Hello? Yeah. No. So we are going now. We're trying to find the procedure of that. I'm not going into details. I'm not going into details at all. The only thing you have to remember is the formula. So if you have data, then you can find b like this, because this and all are derivations. I'm not going to discuss that. So many things are there. So you are going to find b like this. What is that? N is number of data points. Summation of x into y. In the sense, if you have table like this, so this is x and this is y. Summation of x into y, x into y, 152 into 32, some value. This is x into y. 8 into 160, some value you will get here. 6 into 148, you get some value. That is what is your, if you are doing, you will get summation of x into y total, if you are doing summation of all the things, right? So like that, that is what is your summation of x into y, and summation of x into summation of y divided by summation of x square minus summation of x whole square. Okay, that is the formula for finding the slope. Okay, and for finding out the value of a, you can use this value, this formula, that is summation of y minus b into, already you know the value of b. You know the value of b. Value of b is already given. This is the value of b. You can substitute back here in this value, and then you can find the value of a. This is your intercept. Then you got a, then you got b, and you have independent values and you have dependent. This dependent will be demand some cases, and independent can be anything, time t, or maybe you can say number of servicemen or number of salesmen, whatever. You can take any value which is independent of, which is depending upon, which demand is depending upon. Okay. And if you see the, so this is how you can solve the problem. You're just finding the value of x square, you're finding the value of x into y, and this is summation of x, summation of y, summation of x, you are just adding all of them, summation of y, and then you're doing x square is 5 square, 8 square, 6 square, that is what 75, 64, 36. I was just adding all these things, 398. X into y, 5 into 132, 660, 8 into 160, 1280, like that. You are adding all of the stuff, and then you're calculating the summation of x into y. Then you're substituting the values in a and b. You're finding the values of a and b and substituting the a and b, and you're getting the equation. That's it. Once you get the equation, then you can find out whatever you want, substituting the value of x, independent value. So that is the end of forecasting. Any doubts before starting the next topic? That is what is your queuing models. And today we'll discuss queuing models and a little bit on production planning control, and close the industrial engineering part for today. And tomorrow is the last class. In that last class, we're going to discuss basic metrology and very little amount of material science, and then we'll close off complete section 4 for our HAL design training and management training preparation. So give me 1 minute gap so we can have some sip of water and all, and then we'll discuss in 1 minute. Don't go away. 1 minute. Sit back and relax. We'll start. Okay, so let's start. Are you guys here? Okay, good, good, very good. So let's enter into the next topic, that is queuing models. So in queuing models, we are not going to discuss. We are going to discuss only the gate service, of course. HL is gate service, right? So in engineering service, it is little extended, but we are not going to discuss that anyways. What is queuing model? Why we discussing all this queuing models and all? What is the importance of that? Because queuing means this queuing model is very generic. If you assume, if you feel that like sir, this can be applied anywhere, of course it can be applied anywhere, and also it can be applied in the manufacturing perspective as well. So let me discuss what is queuing model. So these queuing models are having so many applications. You take general applications like where is that? Like ATM counter, right? Now in this digital era, nobody is standing in ATM queues. Let us assume, right? Maybe airport, what you say, the check-in. We are doing online check-in, but let's say if you have luggage, then you have to check in, right? Maybe airport security check, let's say security check. You have to stand in queue, right? Movie ticket counters now everybody is buying online, but still let us assume that we are saying no. So these all are general applications. And if you're going for manufacturing perspective, let's say you have a machine, machine one, and you have some objects that are in queue, that are waiting in queue. So this can be applied in your production bay as well. For some product to get machined, or for some product to get assembled, or for some product to get inspected, everything is having queue because there are some thousands of products. Everything will get its own term or own time or own place to do these things, right? So we have to know what we are going to do here. We are trying to find out the probability of getting so and so service within so and so time. So everything what we are going to do here is probability. Please do remember we are discussing, we'll be discussing something on probability. So we are trying to deal all these things with probabilistic in a probabilistic way. Okay, fine. So if you see the aim of queuing theory, aim of queuing models is nothing but achievement of economic balance, right? You should not get frustrated. People should not get frustrated, or maybe the item which is waiting should not get damaged. It should be processed within certain time. There is no, you can't expect, you can't wait, you can't put some product in queue for longer times. Or maybe if your human is there, you're standing in a queue, you can't stand for longer times. You have some patience, right? If you're losing your patience, you're not getting, you are leaving from the queue. It means that the advantage or the profit that the service people are getting from you is being lost because you are not taking service, you're not paying the profit for him, him or her, whatever it is. Okay, so that is the aim of giving service or providing very best service. So it is applied in service-oriented organizations like machine shop, ration repair shop, production shop, workshop, food chain industry, ATM industry, whatever it is, ATM shop, all things. Food chain also, right? You'll go to restaurant, it's huge rush, right? You have to wait because your order is in somewhere in the queue. Maybe you are 20th person visiting that restaurant and you are 15th person ordering the same cuisine or same food item, right? And you're in queue because your turn has to come. So now what we are going to do is that first we have to analyze what exactly is happening in these things. In the sense, now what we have to do is that there is some system. This is what is system. We can assume it to be a bank or ATM machine center or a restaurant or a machining shop, anything you can assume. That is what is system. In that system, you have some person who is sitting in this S, that is what is your service person, means let us assume that is your counter. This is your service counter, right? And all the people, let us assume that you have only single queue and everybody is waiting in the queue, but only the first person, this person is taking the service. First person is taking the service. Is now the people who are waiting behind, right? All these people who are waiting behind, all are in queue. So that's the reason why you see this queue, and this is the person being served. Person being served will not be considered in queue, if you remember, right? You're not standing and waiting. Your service is live, it is happening. And who are standing behind you, let's say you are the person who is getting served, and behind you all the people from here, every person who is standing behind is in queue. Okay? So that is the description of system. Okay, now where these persons are coming from, where these persons are coming from, who is the source for it? So if you are assuming this to be some kind of a bank, let us assume, and the input source or calling population will be the population who has bank account in this most of the time, or who wants to take bank account in that bank, or who are applying loan in that bank. That's it. If you are not related to that bank, you are not going to go there. So the persons who are related to that bank, who is having account or who wants to open a new account or who wants to take some loan, something like that, some relation is there, then only you go to the bank. And all the persons who are related to the bank are input source or calling population. And you know what? All persons will not go to the system on a single day or a single time. Right? Randomly, one fellow will go, here one fellow will go, here one fellow will go. So the arrival to the system is assumed to follow Poisson distribution. That is what is lambda. Arrival rate, arrival of persons to the system for service. And that is denoted by lambda. And this lambda is probability. I'm not sure. It might be 100, it might be 200, it might be 300 in a single day. Over a period of time, if you're taking all the data per hour, if you can take per one day, you can take the data of people arriving to system. If you're plotting that, you can get some kind of a Poisson distribution. So arrival rate is assumed to follow Poisson distribution. Poisson probability distribution, Poisson distribution. Okay. And okay, fine. Now people have come happily and they are standing in queue. Now this fellow is serving, and as your service is done, the people are leaving out. People are leaving. You're taking the service, you're leaving out. And the leaving out persons, the persons who are going out also will have some rate. That is what is the service rate. How many people you are serving in so and so time. Let's assume that in a single day, 100 people are coming, and you are able to serve only 80 people. So it means that 100 people per day are coming. That is what is your lambda, and you have served 80 per day. Then that is what is your service rate, mu. So lambda is 100, mu is 80. So tell me, should arrival rate should be more or service rate should be more? What do you say? The people coming into the system should be more, or people who are leaving should be more? And rate, obviously service rate. You're right. Why? Because let's say this fellow is serving very slowly. People are coming very fast. Big queue will form, and this fellow is very slowly. People are going. Sometimes let us assume that in 10 minutes, 10 people are coming. In 10 minutes, he is serving 20 people. 10 minutes, 10 people are adding. 10 minutes, 10 minutes are adding. In 10 minutes, he is serving so many people. Or maybe in 1 minute, he is serving so many people. Right? So, service rate should be more. Otherwise, the queue will explode. You keep on going and it will explode. Day after tomorrow, some movie release is there. So let's say the service counter, the fellow is not issuing tickets very slowly. He's very old, or maybe he's having some problem, and he's not doing. Maybe system issue is there. His service rate is very slow. Then queue will explode. Right? Obviously, every time for the system to work, what you have to do? The service rate, right? S, the service rate. Okay, not service rate. Service rate is mu. Mu should be always greater than or equal to lambda. Okay, that's it. That are the important points that you have to understand. And please understand that the person who is being served is not included in the queue. The person who is being served is not included in the queue. Please do remember. How many people are there in system? 4 people. Here in this diagram, let us assume that this is the queue. This is complete thing. 3 people are in queue. One person is serving. So 4 people are in the system. At an instant, this is what is happening. Okay. So at an instant, length of system minus length of queue is equal to 1. But on an average, length of system minus length of queue will not be equal to 1. Why, I'll tell you. Okay. So that is what I told you already. So arrival rate or arrival pattern, right? That is lambda, and it is trying to follow the Poisson. It is very random. Therefore, it is going to follow Poisson. And the number of customers or service rate that is happening is mu. Right? And we have seen already these things. Next. And now we are trying to see in which order we want to arrange this persons or jobs in queue. You will follow, let's say this is machine, and these are the jobs waiting in the queue. So you say first come first serve, FCFS. You will say last come first serve. You will say service in random order, or you say priority treatment. What is a priority treatment? Priority means like some object is there, some machining is going on already here. Some object X is there, and it is very urgent that this object has to be manufactured. Then you remove all the things and you load this thing here. So this object has been given the priority, or else you can think of like that. You had some movie ticket counter, and everybody is standing in queue like this, and some celebrity has come, and the celebrity will not stand here, right? Celebrity will directly go take ticket and go. So celebrity is given priority treatment, right? Like that. Or service in random order. What is service in random order? Service in random order is nothing but like lucky draw. If every people are there in a bunch of like this, you don't know whom to serve. You don't know who came first, who came last. Now what you do, you'll pick randomly. Service in random order, right? And already told you system and calling population. System is nothing but the place or facility where the customer arrive in order to get service, and the capacity may be finite or infinite. So please do understand the system can be finite or infinite. The system can be finite or infinite. What is that? What does it mean? I already told you this is your calling population, this is your system, and people are going inside like this. So what I'm saying, the system can be finite, it is denoted by n, or it can be infinite as well. What is that finite and infinite? Let us assume that we have two banks. One is SBA and another is HSBC, Hong Kong and Shanghai Banking Corporation. Okay, this HSBC is for rich people. Right? And generally we can also open, but the minimum balance should be some 5 lakhs, something like that. In SBA, minimum balance is 100 rupees, maybe 1000 rupees now. But in HSBC, minimum 5 lakhs you have to keep minimum balance. So not everyone is going to have HSBC account. Okay, SBA is 0. Okay, fine, good. That is more good. Okay, fine. So HSBC, I think I don't know. I'm saying 5 lakh. It might be anything. I don't know. I'm exaggerating things. I don't know. I'm assuming it to be around 5 lakhs because it is having good reputation, right? So let's say if you're having account in HSBC, it means you are in very limited population. That is finite. Let's say you have account in SBI, infinite. So many people are having. Everybody is having SBI account. Very less number of people are there who is not having SBI account, right? So that is what the system can be finite or infinite. Sorry, the calling population can be finite or infinite. System can be finite and infinite. What is the system? See, this is what I'm talking. The calling population can be finite or infinite, and system also can be finite or infinite. What is system? System is this. Let us assume that this is some motorcycle repair, and car repair. Let us assume, and your car is coming to repair, and some other car is coming to repair, some other car is coming to repair. So you'll come and receive all the cars, and after 50 cars, you'll stop receiving the cars. Why? Because you don't have space for parking, and the customers who are coming don't want to park their vehicles outside the repair shop because it's too sunny, and we are not happy because you don't want to park on a road and you go, right? So the capacity of that system is limited, 50 cars, that's it. The person who is the car who's coming after 50 cars, that person has to leave. That is what is finite. Infinite, movie counter, right? Movie counter is there. It can go and it will go onto the road also. It will keep on going. Initially, when I was a kid, some superstar good movies like good big hero movies are getting released. Let's say the line will go kilometer, 2 kilometer line will go. It is infinite. There is no rule for it, right? So that is what is your system population can be finite and infinite. Calling source population also can be finite and infinite. I told you the example of HSBC and CA, right? Now next is customer analysis, very important. Here some cases this thing will not be applicable to our manufacturing thing, but we can assume it to be saying that the item will not damage for longer waiting time, and item will damage for longer waiting time. That is what you can analyze or make an analogy here. But let's say in a simple generic way, customer can be patient or impatient. Patient, okay, fine, no problem. Impatient, these are the things that fellow will do. What is that? Jockeying, balking, reneging, cheating. So what are these things, sir? Okay, okay, here it is there. So if at all your customer changing the queues for faster service, what is that? You are waiting in one queue. Let's say there are some two queues like this, three service counters are there, and people are waiting here. People are waiting. People are waiting. People are waiting. You first you join this queue. You see that okay, this queue is moving fast. I'll go and I'll join here. Again, oh, I'll join here. So you're moving here and there, so that you want to get faster service. That is what is your jockey. Bulking, customer doesn't join the queue and leave the system as queue is very long. In the sense, queue is very long. It's not, today it's not going to work. Anyways, I'm not going to get the service. You feel like that and you leave. Another is reneging. Reneging is nothing but you wait, you join the queue, you wait for some time, you see that queue is moving very slow, and then you feel and you live in between. Living in between is known as reneging. And another is nothing but cheating. What is that cheating? Customer takes illegal means in hope to get faster service. In the sense, maybe you can bribe the person who is taking your application forms. Maybe you go and fight with that fellow, or maybe you tell some lies saying that something bad is going to happen if I'm not going to leave from here very early. Like that, you do anything but it's cheating. Right? So that is, these all things will be done by impatient customers. Anyways, this thing is not there in our syllabus. I mean, not a big deal, but I'm just saying, okay, for your knowledge. Okay. Next. So we have so many things in our bucket. What are the terminologies in the sense? Okay. What is that? We have probability of distribution for arrival pattern. That is what is your Poisson lambda. Probability distribution of service pattern, exponential. Number of service or counters, right? Service rule or order, that is what is first come first serve, all the things. Size or capacity of system, it can be finite or it can be infinite. Size or capacity of calling service population, here also it can be finite, it can be infinite. So all these things values are there. So I am arranging these values in this kind of form, and that is what is your Kendall and Lee notation. That is A/B/C is to D/E/F. Okay. One example, sir. What kind of example? What can you tell me? If I say that M/M/2 is to SIRO/N/, if I say like this, what does it mean? It means that what is M? M is nothing but Markovian distributions. If you heard of Markovian and all these things, that will come. Under Markovian, you have lambda and mu, and this lambda is Poisson distribution, mu is your exponential distribution. It means that this is lambda, this is mu, and this number of counters are 2. I am doing service in random order, and this the system capacity is finite, and the calling population is infinite. So that is what is your Kendall's and Lee notation. So that is what I'm seeing. So that is what is your Markovian. M is Markovian. This is under Markovian, we have Poisson and exponential. If something is represented as E, that is what is your Erlangian. If something is D, then it is deterministic. Deterministic means no probability now. Everything is determined. So this is what is I've told you, right? Poisson distribution, exponential distribution, number of service counters 2, first come first serve, finite system capacity, infinite calling population. Okay. That is what is your queuing modules. Fine. Now, as I already told you, what do you say? This is not good because your arrival is more than service. That's why the system will fail and we couldn't find any solutions. But this is good. That is, your service is more, or maybe you can say the arrival is less than or equal to service. Service is more. then the system works. When the system works, I don't want to mention lambda mu every time. So what I'll do, I'll take the ratio of lambda by mu and then I'll denote by rho. Rho is equal to lambda by mu. And obviously, as lambda is less than or equal to mu, rho also will be less than or equal to mu. So rho is having so many values, names for it. It can be called as average utilization, system utilization, channel efficiency, clearing ratio. You can tell so many things. Okay. So it also indicates the probability of new customer to wait, but don't worry, I'll tell you what is that. Now, very important formulas. Come on, here you have to remember all these formulas. It's very important. Please be attentive. Okay. The first formula that you're going to remember is this. That is this formula. This formula you have to remember. What is that? Pn is equal to rho to the power of n p naught. What is Pn? Probability that n customers are waiting in the system. In the system, in the sense, the person who is being served also will be considered, not queue, in the system. So n persons waiting in the system, n persons in the system, right? So here it is Pn, probability of n persons waiting in the system, is equal to rho, that is your clearing ratio or channel efficiency we have seen, right? Lambda by mu to the power of n into p naught. What is p naught? P naught is probability that the system is idle. Nobody is there in the system. People in the counter are sitting idle. Nobody is there. Okay. Then how do you find that? So you know already, for a certain instant, for a certain day, the probability of 0% in the system plus the probability of 1% in the system plus the probability of 2% in the system plus probability of 3%, still probability of infinite people in the system will be equal to 1, because that is what is your probability basic rule. The summation of all the probabilities should be equal to 1. Right? That is what is infinitely performing some task, isn't it? If you have a coin, right, then the coin is very unbiased, in the sense you have heads and tails. So you repeat this experiment. First time heads, second time tails, heads, tails, heads, tails, like that. You repeat it for infinite times. Then only you can say that probability of heads is equal to 0.5, probability of tail is equal to 0.5. You repeat that experiment for so many times, that is infinite amount of times, isn't it? Like that. If your summation of both the probabilities, summation of probabilities, that is summation of probability of head plus probability of tails, should be equal to 1. That is what is your important rule in probability. Okay. In the same way, probability of 0 people waiting plus probability of 1 people waiting, so on, probability of infinite people waiting is equal to 1. Right? So if you are expanding that, this is that, and you know this formula, the substitute P1 is equal to rho to the power of 1 into P0. That is what is this. P2 is rho to the power of 2. That is this P2. P3, like that till infinity. Okay. And if you do some manipulation, you will get P0 is equal to 1 minus rho. Okay. P0 is equal to 1 minus rho. Again, this is one more important formula. This is important formula, this is important formula, and this is important formula. Probability of 0% waiting in the system is equal to 1 minus rho. Rho is nothing but lambda by mu. Rho is lambda by. Is it clear? Hello? Guys? Okay. Good. Now, so this formula will give you the average number of customers waiting in the system. That is length of the system. Length of the system, please, I'm telling, the person who is being served also will be considered in system. This system. and this is Q. Average number of customers. What is average? Morning 2 people will be there. Afternoon 100 people will be there. Evening 5 people will be there. In some between 50 people will be there. At an instant, if you take on an average, what is the length? Average I'm saying. It's not an instant value. So this is the formula. That is summation of 0 to infinity. N is equal to 0 to infinity. N into Pn. That is, you are finding out all the formulas and you'll find out the formula as this one. Length of the system. Average number of people waiting in the system is rho by 1 minus rho. Very important formula. Okay. Length of the system is equal to rho by 1 minus rho. And you already know rho is arrival rate by service rate. Arrival rate by time, service rate by time, okay, with respect to time. Okay. Next. This is the average number of people waiting in queue. Queue. Okay, in the sense, if this is completely counter, this is counter and first person is in. So this is on. This is queue. So from here this queue. So average number of waiting in the queue. It means the person who is taking the service will not be considered. Okay. Then the formula is this. Rho square by 1 minus rho. Same thing here, it is rho by 1 minus rho. Here it is just you have to multiply with rho, that is rho square by 1 minus rho. Is it clear, guys? Please try to remember these formulas. Anyways, I'm not telling the derivations because derivation is here, but I'm not going to say because we have limited time. Fine. And now length of system and the length of queue. Already, if you see, this is counter X like this. So this is Q. This is length of Q, LQ, and this is length of system. You might say, sir, length of system minus length of Q is equal to 1. No, it is not equal to 1. Why? Here we are not considering at instant. We are saying average. We are saying average means throughout the day or throughout the month, something like that we are considering. On an average, if you are doing, it is equal to rho. It is not equal to 1 because we have already have told you here it is average and here it is. Please, length of the system minus length of the queue will be equal to rho. Good. And it's not only length. We can see the average number of average waiting time. How much time a customer has to wait in the system, and how much time a customer has to wait in the queue. Okay. So the customer waiting in the system, average waiting time is WS and average waiting time is WQ. It's nothing but WQ is equal to LQ by lambda and WS also is LS by lambda. These are given by Little's law. Actually, this is Little's law. From here we are getting this. L is length, W is waiting time. That is again average on an average. It's not for a single customer. On an average, how much time a customer is waiting, each customer. If I'm waiting 20 minutes, you are waiting for 10 minutes. Somebody is waiting for some other 30 minutes, right? So 20 plus 10 plus 30 60 divided by 3 is 20 minutes. Average waiting time is 20. Okay, that's what is that. And the probability of, now probability is coming. The probability of, very important, I'm just decoding these things, please try to listen. The probability of waiting time in system greater than time t. This is all very important. What will I say? Let's say some service is going on. I'll say, you will go and ask, let's say you're going to the repair shop person and you'll say that, what is the time that my car is going to take service? He won't say single time. He'll say, come at 4:30, I'll complete it. You can't say. Lagbhag, I think it will take till 5:30, sir. Then he'll ask, what is the probability that I can complete? You can complete it by 4:30. You'll ask him, is there any way or is there any probability that you can complete and give my car by 4:30? Then we will say, sir, 80% हो जाएगा sir, 80% I'll complete sir, 80%. He will not say 100%, right? And that is what is this value. Probability that you can complete your waiting time is more than some time t. What is the probability that I have to wait in the garage after 4:30? That is what is given by e to the power of minus t by Ws. Ws is average waiting time in system. Okay. In the same way, you can have probability waiting time in queue. Here it is system. The system is, you will say, sir, even though the car is being serviced, you have to wait there, no? And sometimes your car is not being serviced, it's still in queue. It has to go to the service person, then only you'll do the service. So then the formula is this. Same thing here, just you multiply rho. That's it. Just rho multiplying to the previous formula. Rho into e to the power of minus t by Ws. And probability of n arrivals. This is what is Poisson distribution formula. Poisson distribution formula is this. Okay. Probability of n persons coming in time t. Arrival rate n by t. But the rate is given by distribution. That is what it says, e to the power of minus lambda t into lambda t into t to the power of n by lambda t. This is the Poisson distribution formula. And service rate is nothing but how many people are leaving the system, and that is also having a probability distribution, that is exponential formula. Okay. That's the end of your queuing models. Any doubts, sir? That is the end of your queuing models. Okay. So we will, of course, I will try to get some problems from in tomorrow, because I think time will not permit. But what I'll do is that I will very fastly, in the first hour itself, I will very fastly cover metrology and materials, because at least we'll see some few problems in the last hour of our discussion. Some problems which are very important, maybe I'll try to find out some important problems, because not solving a problem also is bad. So that's what we have discussed. So if you see here, we have discussed inventory control, we have discussed operational research, we have discussed percent CPM, we have discussed forecasting and queuing models, then we are going to discuss the the production planning and control. Here also, I'm not going to discuss in detail. I'll give you a very brief intro about that, and I'm hoping there won't be any question, but I'll tell you some basics so that it will be very important for you. So let's start the production planning and control as well. Okay. So here I'll just go on a fly, because these things are very not important for gate also. Not important in the sense the topic is important, but the weightage is very low. Hardly you'll find a question per gate. That's why I'm just moving very fast. Okay. So if you see here, the important factors for a company is quality, quantity, cost, time. Quality and quantity should be more. Cost and time should be less. So we have to improve these two. We have to minimize these two, reduce these two. You have to reduce the cost and you have to reduce the time also. Time for producing, cost of item, quality of item, quantity of item. So quantity of item, quality of item should be improved. Cost and time should be minimized. And for these three, in any production bay, I told you already, 3PM system is very important. That is manpower, machine, and material. All these three things should be working in tandem. In the sense, skilled labor should be there. Very good equipment should be there with good precision and accuracy. Material should not have any defects. Proper material has to be provided. That's it. Properly you can do all these things. Skilled labor is there. Minimum time will take. More quality and more quantity will produce. Thus, quality is there, cost will be high. Production cost will be low, profit will be high. Good machine is there, good. Good material is there, good. Yeah. and this and all will skip. And sometimes there is another M that is added, that is your manufacturing process. Manufacturing process. So 4 M's: man, material, man, machine, material, manufacturing process. Which manufacturing process also you're selecting is very important. I can make some object by casting, or I can make the product by machining, or I can make the product by additive manufacturing. What are you going to choose? It's very important. Next, production control. Okay, so that is what is important. How do you want to control the production? Because you might have planned something. Where is that planning and all? Yeah. Once the plan is prepared, you will plan something. The execution of plan and perform in the line with the user plan. Production control comes in the action if there is deviation between the actual and plan. Okay. So you planned something. You told that, okay, I'll complete all the production by mid-April. That is planned one. But due to some unavoidable circumstances, you couldn't complete that. Then that is what has actually happened. Then as the planned one is not reached, or the actual is deviating from the plan, then there is an error. Then there is a deviation. And that deviation is what you have to control. You have to control that. And that is what is known as production planning and control. Production has to happen. Planning you are doing. The deviation you are controlling. That is why it is called production planning control. Is it okay? Yes. And it's an all theory, man. Full theory. I'm not sure, but it's very important because read 1,000 slides, but it's not going to help you. Important concepts. Yeah. In planning, we have different stages: active phase, action phase, and control phase. In planning phase, we have prior planning. Like these are very important. This is what we want to discuss. That is your aggregate planning, master scheduling, MRP, material requirement planning. All these things are prior plannings before production starting. After production starting, active planning will come. That is your process planning, routing, materials, where to send where, loading, scheduling, how many tools. All these things are during the production. These are before the production. Right? And action phase is nothing but dispatching. Dispatching in the sense of one of the things are done, then we are dispatching. In control phase, one is progress reporting, that is what is your data processing. Another is your preventive actions, that is your corrective actions are expediting, replanning. You are just replanning it. You are just changing your plan, or maybe you are doing something else to make sure that you are going according to the plan. Okay. And the next is this and all we have discussed. Material requirement planning is very important. What is that? Material requirement planning is nothing but the technique for determining the quantity and timing for the acquisition of dependent demands. Okay, so to break this down, I'll give you an example. The example is in the right hand side bottom. What is that? Your car is there, 20 cars. You want to manufacture. And for a car, you are assuming that 4 wheels are required and one stepney, one extra wheel is there. So you want to manufacture 5 cars. And you want to make some 3 seats, front 2 seats and back full 1 seat. And then windshield. There are so many products. So like that, let's say you take a single wheel. In a wheel, we have tires and spokes. So like that, these are the basic. This is kind of a tree. Right? This is root, and then we have branches and leaves. These are leaves. Right? These are the basic products that are required, which are independent, but these are dependents of when the car is depending upon these values. Now, what is the quantity of tires? And what is the quantity of spokes that I have to manufacture? And by which time I have to send these things is what you are planning. That is what you are planning, right? How many quantity, and what time right? That planning is what is your, the planning of these tires and spokes is your material requirement. Thus, dependent demand items. This car, until unless you are manufacturing this car cannot be manufactured, right? So these are your material requirement planning. Is it clear? MRP? Okay, fine. Now, so these are the objectives. Let me not details. I'll tell you what is the basic stuff. So this is MRP system. In MRP system, we have 4 important things: master production schedule, inventory status file, bill of materials, and then, okay, this diagram is very important. Okay, see that. So I want to find out how many items and when I am going to deliver them. That is what is my plan here. That is your material requirement planning. For that, I need some inputs. I have to know some inputs, right? I want to have the present status of something. So the inputs are master production schedule. So what was the master, on a large scale, what is going to happen? You have to know that. That is what is your master. So master production schedule. MPS is a time-phased quantities for each item that company produces, indicating how many are to be produced and when. MPS is initially developed from firm customer orders to form forecast and all. So what is an MPS? How many cars have to manufacture? Then only know how many tires and spokes have to manufacture. So how many of depending items have to, till what time? Obviously, this also have time. I have to deliver cars by mid-April. Okay, maybe I have to manufacture and produce this tires and spokes by end of March, right? So depending upon this only, this will come. So that's the reason why MPS is input for MRP. And inventory status file. What is, how much inventory is there? Should I order something now because lead time is there? How much is there with me right now? How much raw material, everything is there with me right now. Then bill of materials. What is that inventory status file? You see, every inventory plan must be having inventory status file, which gives complete and up-to-date information on hand quantities. Very important, right? Bill of materials. Bill of materials identify how each product is manufactured, specifying all the subcomponents, and this bill of materials will give you everything. You say that, okay, for manufacturing tires and spokes, you have to do so and so procedure, all the things. So this will give you importance for the time. This will give the importance for the quantity. This will give you the time as well. So like that, all the inputs you can give to the MRP system, then it will produce the output as order release time. This is when I'm going to give order rescheduling. If something is happening, then I'll reschedule it, and then this is your future that is going to happen. So these are all the outputs of MRP, but inputs are important. This can be a question as well. What are the inputs of MRP? Master production schedule, inventory status file, and bill of materials are the answer. Okay. And next is aggregate production planning. What is aggregate production planning? It's nothing but I want to plan. I want to establish some company, or maybe I'm in a business. Okay. So I can't do a long-term planning because it might fail or hit. I don't know. So I'll do a minimal basic planning that what are the raw material that is required so that my production will be in run for next 6 to 6 months, 3 to 6 months. So concerned with planning overall production for all products combined in terms of steel, liters and everything for over a planning horizon of 3 to 6 months. That is what is your aggregate production planning. First, some forecast has come. So for some 20 cars. For 20 cars, so and so capacities, cost, everything is written. And for 6 months, you are planning this first. You are not going to say that like next 5 years is this. First 6 months, you will give something, right? That is what is your aggregate production planning. From aggregate production planning, what will get output? You'll say that, okay, for the next 6 months, I need such and such workforce. I need some machine time, allocation, all these things you'll say. For next 6 months. Why? Why, sir? Why we are doing aggregate production planning? Because I can't, it's not India. So in India, you'll hire a person for his lifetime. In the sense, like if you want to join a manufacturing company, as some kind of a machinist, you are very good in some machine. Let's say we didn't do BTech, we did diploma, okay, and then we joined into some manufacturing there, and we are trying to run a machine. If you're working in a government company, your lifetime is settling there. But if you're joining in a private firm, if you're working in a foreign company, it's not sure. First, he'll hire you for 6 months. Then, based on your performance, either he'll fire you, or maybe he'll give you some incentives, and he'll keep it the firm itself. You're in the firm. So you can't say that, okay, once you're in, you're here for your lifetime. No. That is what is your course. But machine time also. How much time? So that is what is your aggregate production planning. Right? And that's the end of your production planning and but I didn't tell complete things, but it's a 15 minutes discussion on what you say, the production planning and control. So all these things are same thing. MRP process area, MTS, bill of materials, everything is same here. That's why I'm not discussing them. Okay. So that's it, guys. That's the end of your complete industrial part. There's one more thing, lean manufacturing. I'll just show the slides, but I haven't seen any questions asked in GATE. And this syllabus has been added recently. I'm not sure whether HL will be asking the questions from lean manufacturing, but I have the slides. Maybe I will ask Dinesh and I'll send you the slides. You can go through very limited slides. You can go through them. Okay. I'm not sure whether this will be asked. Okay. Anyways, I'll explain this cellular manufacturing. Okay, I'll explain this funda. It's very important. Maybe it will be asked or not. I don't know. But anyways, what is the funda here? This is your functional layout. Okay, this is your functional layout, and this is your cellular layout. In the sense, I am splitting my operations into group. I'm clustering my operations into group. That is what I'm saying. So let's say you have some machine 1, machine 2, machine 3, machine 4, like this you have, and some product is coming. It has to roam in a very zigzag way. It's very complicated. What's going to happen? I'm very confused. Let's say that product requires some certain operations, maybe milling, drilling, and boring. That related machines are put in product cell B, work cell. So product B is coming, then it will go to this cell. All the things will be done here, and then it will go out. But in the previous case, milling machine will be here, drilling machine will be here, boring machine will be here. First it had to do milling, boring, then go out. Very complicated. So product-wise, you are splitting the workspace and then putting the corresponding machines in that workspace is known as work cell. And you're doing that cell-wise, you're arranging that machines. And these cells are having machines, and that machines are based on your products. Okay? That is what is your difference between functional layout and cellular layout. Isn't it? Are you getting my points, guys? Hello? Yeah. Fine. So with this, I will close the industrial engineering part, and we are left with metrology inspection and materials, and that also we'll be doing tomorrow. In the first 1 hour, we'll discuss about basics on metrology inspection, and then materials. I'm not sure because it's a very vast subject. It itself will. If you forget itself, it will take some 5 to 6 hours. That is minimum. If you want to extend it, will go to 10 hours also. Okay. So we don't have much time, but I'll give you very, very important points, crisp points. Try to note them, and maybe you can remember them. And if some kind of questions which are related to that are coming, then you can remember them. Okay. And I hope you are practicing the questions, because I already mentioned that practicing questions are very important. Why I am concentrating on concepts? Because if one concept you are learning, you can solve 100 problems. But if you are solving 100 problems, doesn't mean that you are learning a concept, isn't it? Right? That's the reason why mostly Dinesh sir and all the faculty, we have all met in a meeting. I mean, before starting these classes, we have all met in online virtually, and we have discussed how we are going to deal with you guys, because very limited amount of time is there, and we have to complete large syllabus. So then we have discussed, and then we thought that solving so many questions will not improve your skill, rather will concentrate on concepts. That's the reason why we are unable to solve some beautiful questions. But anyways, nevertheless, we were able to complete some syllabus, right, on a fly. I mean, on fly in the sense like not very deeper that we went, but we completed on a progress. Fine. So with this, I'll close for today's session. I think you have another class at 8:30, and tomorrow will be our last class. And I hope you have enjoyed till this point, and tomorrow also we'll do in the same way. And if you have any queries or if you have any suggestions from your side regarding my teaching or regarding my way of presenting or regarding the concept that I have covered, or if you have any technical doubts on any of the subjects that we have covered, that is your way to your metal casting, forming, cutting, welding, PERT and CPM, inventory control, operations research, all the things we have discussed, right? Any doubts, any peculiar doubts, any specific doubts, anything you can ask tomorrow. Okay. I was not there when you were teaching. I didn't get you, Naveen. What is that? Average modeling. What is that average modeling? Average modeling. In which topic, Naveen? What do you want? Okay. So actually, you can revisit the video because the video will be uploaded. If you have any doubt yet, please let me know, because I can't repeat it again because your time is done. You have to have your dinner and you have to start your next class, right? So just to see the video. You have the recording, right, in YouTube. Just see the video, you get it. If you're not getting, please do message in the WhatsApp. I'm here to explain you. Okay? Yeah. Okay. Yeah. Okay. Fine. So carry on for the next class. Thank you all. Let's meet tomorrow.